Welcome to Rges Algebra 1. This is lesson 27A. And of course, because of health concerns, we will not be having class for the next 3 weeks. So instead, what I will be doing is first on the tape, I will be going ahead and giving you your answers from your homework for the previous lesson. So today I'll be doing that by giving you the answers to 11.1 and 11.2, and reviewing those concepts. Then speaking of our new concepts, 11.3 and 11.4, and then going ahead and giving you the homework assignment that will be due on Wednesday. Please try to keep up even just as though you are coming to class as best you can. Before we begin, I would just like to put up a scripture for reflection. This says, "Blessed be the Lord who daily bears us up. God is our salvation." Just a reminder how much He loves us, how much He is concerned for us, how much we can daily look to Him for courage, for strength, for peace, for wisdom, for all that we need. He daily bears us up. He carries us in His arms and wants to be our salvation. Meaning what? Not only the one who forgives us from our sins, which He is that, but the one who gives us His own life in exchange for ours. The one who gives us all we need as we call to Him. So I want to encourage you with that, and then I will go ahead. You can go ahead and collect your homework together so you can check your answers. So I've given you the answers to the even problems for 11.1. Any that you miss, whether the even or the odd, please go back, and first thing you should do is try to redo that one problem again. And if you still cannot find the answer, go ahead and study the method that I've shown you and illustrated for the even problems, and then see if you can go back and find fix any issues you had with the odd ones again. Now, for 11.2, all your problems assigned were odd, and so you have all the answers in the back of your book, but I'm going to do several problems for you of the odd ones, choosing several different levels of complexity to make sure that you're understanding the idea. So this will be our way to review the concepts in 11.2. Okay, so this finishes the review of several problems on 11.2. Feel free to put it, of course, on pause, go back to the previous page, go to this page, and hopefully that will clear up any questions you have. Now, I am inviting you to go ahead and text my number, which I'll put on the top of the next page, if you have any further concepts or any of these concepts or any other concepts that you are still confused about and need additional review. If you send just a quick text to me and tell me I still don't understand whatever kind of problem, then on Wednesday's tape, I will make sure to review that also for you, since we do not have any class time for additional questions. Now in section 11.3, we're going to be working on multiplying and dividing rational expressions. There really is no new concept being taught here. What we're doing is we are adding the idea. We've already learned how to simplify rational expressions, and now we're adding that concept to the concept of multiplying and dividing rational expressions. Remember, rational expressions meaning ratios or fractions. And you already know how to multiply and divide. So we're just concatenating two concepts you have already learned how to do. So let's review. To multiply, we multiply straight across. We cancel if we can. We multiply straight across. Numerator times numerator. sorry, my writing utensil's not working, here we go, is 6. Denominator times denominator is 35. If I did not cancel ahead of time, review it again to make sure you cannot cancel, and that's all you do. Recall to divide, you multiply by the reciprocal. The second one is you multiply by, so it's the second term, not the first term, that's being changed. So you have 2/5 times 7/3. Make sure you cannot cancel, multiply straight across. 2 times 7 is 14, and 5 times 3 is 15. And that's all we're going to be doing. But now we're going to be doing it with rational expressions. So here, in this one, we'll multiply straight across, but we can feel free to cancel anything, right? So what do I mean by that? Well, let's see, a 12 and an 18, 6 goes into each of those, goes in 2 times and 3 times. A 15 and a 20, a 5 goes into each of those, goes in 3 times and 4 times. Nothing else can cancel. Okay, so what do I have when I multiply straight across? 2 times 4 is 8 in the numerator. X times x is x squared in the numerator. And 3 times 3 is 9 in the denominator. And that's all you need to do. When I want to divide, the first step should be change this to a multiply. So this will be, leave the first term alone. 12x over 15, copy it as you see it, change the second term to its reciprocal, but now we're multiplying. So this will be 18 over 20x. Divide anything you can. Okay, I see that a 3 goes into 15 5 times, and a 3 goes into 18 6 times. I see that let's see, what else do I want to do? Let's say I want to say a 2 goes into, how about a 4? A 4 goes into 12 3 times. A 4 goes into 20 5 times. My x's cancel, nothing else cancels, so multiplying just the numerator, I get 3 times 6, or 18 over 5 times 5, or 25. The biggest issue you will have is making sure your answer is most simplified. You can always check it again at the end. Is there anything that can divide evenly into both of these? And not losing things I haven't canceled. In other words, when it gets sloppy looking like this, and I've canceled some things and I have other things not, I can easily miss something. Maybe I hadn't canceled my x's as a, and I might have missed one, something like that. So that's where you have to be careful, is making sure when I multiply straight across, I've gathered everything that hasn't been canceled. Now, when we go on to a more difficult problem then, what I want to do is, first thing, I'm going to change it to a multiplication problem. You could do 2 steps in one if you want, but if you have any inclination to forget something, then go ahead and break it out and do it in steps. Because I always say paper is cheap when you're doing mathematics. In other words, sometimes when I'm trying to save paper by doing 2 steps in my mind, that's where the student makes the errors. So if I'm changing from division to a multiplication, the first term is copied straight down, the second term is going to be reversed. Now, what do you think I'll do in this next step? I'm going to factor every grouping. I've got 1, 2, 3, 4 groupings, right? The numerator there, the denominator there, the numerator over here, and the denominator over here. I'm going to factor each group. Okay. So here I will get x minus 5 times x plus 3. What do we tell you? FOIL. Make sure x squared, outer plus 3 minus 5 would be minus 2, and minus 5 times positive 3 is negative 15. Okay, that works. The denominator, pull out a 4x, factor out a 4x. leaving me with x plus 2. We would distribute to check that. Over here, factor out a 4, leaving me with x minus 5. And here there is no factoring to be done. Look at it as a group. See that? So now what I have is a bunch of factors. I have no addition and subtractions except within multiplications, within the parentheses. So that's very important because you cannot factor without that. This will factor out. The 4 will factor out. Nothing else factors out. So here I'm going to get, for my numerator, x minus 5 twice over x times x plus 2. Now that, in my mind, is a very acceptable answer because it is factored completely. Or I can go ahead, and you might need to keep in track with his answers. For my answers, for my tests or quizzes, that's perfectly good. Or you can distribute it out again. X minus 5, the quantity squared would be x squared minus 10x plus 25, distributing my x in the denominator, x squared plus 2x. Either answer is perfectly fine. Again, you might need to do this extra step to identify his answers and whether or not yours are correct and in match with his. Let's take a look if there's anything else I want to tell you about this. Okay, let's say we are in 11.4, we're talking about the least common multiple. Multiples, you know what a multiple of 3 would be 3, 6, 9, 12, 15, 18, etc. A multiple of 2 would be 2, 4, 6, 8, 10. Okay, and what you're talking about when you're talking about the least common multiple, you are comparing two or more terms, and you want to know where do they have the first common multiple, the first multiple they share together, and you want the lowest one. So example, if I have 3, my multiples of 3 are 3, 6, 9, 12, 15, 18, etc. My multiples of 4 are 4, 8, 12, 16. I could keep going on, but what do I recognize? They share a 12. So the least common multiple between 3 and 4 is 12. What if I were looking at x's? X cubed, okay? If I multiply one more, it works a little different. If I multiply one more, I get x to the 4th, then x to the 5th, and here I start with x to the 5th. So they share the x to the 5th. So when I'm doing variables and comparing exponents, when I'm looking for the least common multiple, I'm always going to take the larger exponent. So x to the 5th is what I want here. Okay. What I want here is 12. So we're thinking, our minds are going to be thinking in a little bit different direction just because of these exponents. It's actually much simpler. So let me give you several examples here. We'll go to the next page. Now for larger numbers, one additional idea is like 6 and 8. They're not too large, but we are going to think rather than counting by multiples, because if I give you numbers like 89 and 22, and I want to find the least common multiples, I don't want to be counting out great large numbers like that. So I'm going to show you an easier way. Break it into its primes. Rather than writing 2 to the 3rd, I'll write it out like this. Now, what is the greatest number of 2's I have in any one? I have 1, 2 here, one of the number 2, the value 2, and I have 3 of them here. So I'm going to choose the larger. This is actually going how we're thinking more about exponents. And then don't forget what is the greatest number of 3's I have. So don't leave off the next number. And I have 3 there and no 3's here, so that would be 3. Multiplying that out, I would get 8 times 3, or 24. So the least common multiple between 6 and 8 would be 24. If I counted out by 6s and I counted out by 8s, the first time I'd find something they shared would be 24. Another way I could define it in my mind is I say that is the first number that both 8 and 24 divide by evenly. Okay. So let me give you a few more examples. A squared b to the 5th and 18 a to the 3rd bc. The harder part of the problem is just the numerical part. So break that out. I'm going to say break it to its primes. That would be 2 times 3. 18 would be 2 times 3 times 3. The largest number of 2's in any one would be 2 squared. The largest number of 3's in any one would be 3 squared. Multiplying it back, I'm going to get 4 times 9, or 36. So that's my number part. Now, what do I do for the variable part? I'm asking, what is the least common denominator here? Okay, there, my number part is 36. Again, I could be just thinking in my mind, okay, 12, 24, 36, and 18 goes into 36 also. So I could just think about them mentally, if I can, with the smaller ones, but not with the larger ones. What about A's? I need the largest exponent. What about B's? I need the largest. What about C's? I need the largest. And this is my least common multiple. Let's try another one. For the numerical part, I'm thinking 9, which is 3 times 3. Some of these you'll start doing in your head very easily. This will be 2 times 3. The largest number of 2's in any one. The largest number of 3's in any one. Multiply it back. 9 times 2 is 18. Now go back to the original problem. My least common multiple for this whole thing would be 18 for the numerical part. How many x's do I have? The greatest number in any one is x to the 4th versus x to the 1. This, you must consider your binomial as a grouping. How many of those do I have? The greatest number in either one is that, and that's my least common multiple. I'll show you another kind of problem here on the top of the next page, or the next half of the page. What if I want the least common multiple of, not a fraction, but these two terms, polynomials? What do you think I'd have to do? Well, I'm going to have to factor. Okay, so the first one here, let's put it on pause for a minute. Once I've factored, I'm thinking the exact same way. I have 3 different polynomials. The first one is here. I have it only one time. The second polynomial, I'm just kind of putting these in an order that makes sense to me. I have it only one time. The third polynomial, I have it once here and once here. What's the greatest number in any one? One time. And that's my least common multiple. Okay. So I think that this is a fair explanation that should get you going. Hopefully you'll find this to be fairly straightforward, and if not, of course, we'll be going over all the answers on our next tape and doing some selected review. So your homework is this here. I would highly recommend that you keep up with your homework just as though you were coming to class. Make sure you have this finished by Wednesday and watch the next tape on Wednesday. Keep your common schedule and things will not be too difficult for you when we do eventually meet again. Or if we start having quizzes and tests that you have to do online. All right, so don't fall behind. And we'll review it next time. And again, if you need a little more detailed explanation, I will be doing some selected review, but if you need additional explanation for this and it's not covered next time, go ahead and shoot me that text so that I know that you need it more carefully explained to you. Okay, have a blessed time. Trust in God. Enjoy this Sabbath season. And be sensitive to your neighbors and those around you, both by taking safety and health precautions, but also by reaching out and seeing what they might need. God bless you all. Bye now.